This is the final video in going through the notes on linear regression. We have two final things to look at here. We have standard deviation of residuals, and then we have the coefficient of determination. People oftentimes mix that up with correlation, but two different things. Standard deviation of residuals, the formula is right there, but typically it's going to be given to you guys in a box of data. We'll look at that in another example problem. But usually it's identified as just S, and that's the standard deviation of residuals. There are other cases, like next spring when we're going to deal with linear regression, and you'll see an S, but it'll have a little b right next to it, and that's standard deviation of the slope. So if you ever see just an S by itself, that is standard deviation of the residuals, and that's the typical prediction error. Like on average, the prediction is off by that much. So your calculator doesn't give this value to you. You'd have to calculate it by hand, but I'll show you another problem in a future video where it is given to you, and yet you just have to be able to describe it. So you don't have to be able to calculate it on your own. R squared is given to you when you find or when you press linear regression on your calculator. So on the truck data problem, it gives you A, it gives you B, it gives you R squared and R. And R on our problem was 0.6642. Yes, it is the square of R. So I think on our problem it was negative 0.8150. So if you were to square negative 0.8150, you get 0.6642. I'm just typing to make sure. And yes, it is. So, or if you're given R squared, you can square root it, and you have R. But notice right here, it is the variation in Y. That is crucial that you remember that phrase. The rest of it, it's kind of important, but the variation in Y is what it's describing. This is almost like a grade that your linear regression model is getting. It's out of 100%. So in this one, it is 66.42%. So the higher R squared is, the better it is, because it's like a grade of how good it's accounting for how much the dots are moving around. It's like how good of a job does the line do at matching with those dots. And on this problem, it's a 66.42%, and it's hard to say whether that's good or bad. This number is more useful to like compare to other models. So if we were to run some kind of quadratic model or something like that and compare the two R squareds, the one that has a higher R squared is better. I mean, closer to 100% is good, but all we're going to say is, in this case, 66.2%, 0.42% of the variation in price is explained by a linear relationship with mileage. I guess I'll throw in of Ford F-150s. So you need context. This is Y right here. This is X right here. And I cannot emphasize enough, this phrase right here is crucial. That tells me you know what you're talking about. Even if you don't. You can memorize that phrase and then say the rest, and you're good to go. It may be a multiple choice problem, and they may flip these two words And you got to be able to catch that and know it's not correct. So we're looking for the answer that describes variation in y. All right. And that's it for linear regression. I'll post another video talking about that data set that you got to be prepared to read. But that's about it. See y'all later. Bye.